Hey there, reloaders. Welcome back to the channel. This is the CS7.1 build series, and today we're going to be covering the assembly and the setup of the electronics module. So let's jump right in. So everything starts with the Arduino Uno, and this is going to be the brains of the operation. We're going to load our code onto the Uno. But before we get into this, I want to show you a couple different Unos here. The one on the right is a Chinese clone Uno. The one on the left is Elegoo, also a Chinese made. Neither of these is original. I have an original one coming, and I'll switch it out with that when it gets here. For now, we're just going to use the blue knockoff. Okay, I need to download the code and then upload it to the Arduino to make sure the Arduino is working. So in the repo, I go to the CS7.1 Arduino file and double click it. This is going to launch the Arduino IDE. If you haven't installed it yet, you're going to need to do that from their website. The code will load up and it will show an Arduino is not connected, so I plug mine in. At this point, I'm ready now to program. And so I simply have to choose the board type, the port. I'll hit Get Board Info. That makes sure I'm connected. Once that's completed, I'm ready to upload my code. So I'll go over and hit the upload button, which is the second button in the IDE. After a bit, you'll see the upload is complete. Mine is showing some extra stuff you might not see. But with that, I have uploaded the code. And now it's time to test it a little bit to make sure it's working. But before we do that, we've got to change a couple parameters because none of our stuff is hooked up yet. So we'll set these 4 parameters to false, and then we'll upload the code once more. Now we can test the code in our serial console once the upload completes and make sure we're getting a ready and a done response. So I open the serial console by hitting Control-Shift-M, and there I see a ready, and now I'm going to send a 0 and make sure I get done. That means our code is working and it has been uploaded successfully. Okay, now we're ready to start wiring up this mess. I have a whole bundle of wires here that I've prepared ahead of time. It might not look like it, but there's been a little work done on some of these. You'll see I've stripped out some ends and I've installed the DuPont connectors on them as well. So the red, black, and white wires are our homing sensor wires, and the 4 color wires are motor wires. And we have a proximity sensor wire here, which is brown, blue, and black. You'll notice DuPont connectors are on all the signal feeds. In this case, brown is 12 volt, blue is ground, and black is the signal. And then finally, I have a motor wire, which I've repurposed for use for the camera module. So it has a red and blue wire, which is going to be to power the fan, and the green and black will be to power the light ring. Because the fan is 12 volt and I don't want to mess that up, I have put a little mark on the connector so that I can align that to the fan the right way every time. So here's our ball of wire, and let's get started and start plugging this stuff in. We're going to do this outside of the case, and this will help us to have a better idea of what's going on, and then we'll be able to test it before we start stuffing the stuff into the case. So we're starting with the motor shield, and you'll notice I've already wired it up with about a foot long 16 AUG power cable that's going to power 12 volt to the shield. And before we install the shield onto the Arduino, we need to put some jumpers in place. And there's 7 jumpers that we're going to be installing. Essentially, we're going to install 3 here and 3 here, and then 1 on top of the enable. So if you forget this step, it's kind of a pain, but you can come back later and do it. Your motors won't run unless these jumpers are in place. These are standard 2-pin jumpers. You'll find them in lots of old computers, or you can buy a bag of them on Amazon for a few bucks. Next, we're going to install our motor controllers. These are TCM2209s, and they come with a heatsink. The heatsink has this double-sided thermal tape, and you'll peel the protective cover and then you need to very carefully align these. Once you get them on, it's pretty hard to change it. And you'll notice these are aluminum, and they're really close to those pins, so you don't want to skew them so they're shorting out the pins. I'm not sure if they would or not, if the coating protects them or not, but I try to make sure they have clearance. You want to install these so that the potentiometer is facing well, towards the outer edge of the board in the orientation that I'm installing them here. If you install this backwards, it is possible you will smoke your controller, and that's no fun. Just double check that you have good clearance between the pins and the heatsink. This one looks pretty good. So now we're going to connect the shield to the Arduino. This is fairly simple. We're really just going to line these pins up and press them together. Don't force it here. You don't want to bend these pins. That can be a real pain. Now, as luck would have it, the Amazon van just pulled up and delivered my authentic Arduino Uno. Ooh, isn't it pretty? So before I get too far into this, I might as well switch it out. This is what I want to use. I prefer to use the authentic Arduino Uno as you get better stability and reliability overall. So this is going to be easy. I simply have to disconnect the knockoff and connect the real one right up. You'll notice the labeling is very nice on the authentic Uno. So now it's time to create our rails, and I like to use these flip lock or clamp lock connectors, mainly because they're just super easy. If you get something wrong, you can fix it quickly. So I have three. I'm going to have three rails, essentially a 12-volt rail, a 5-volt rail, and ground. So we'll start by running my ground wire to what's going to be my ground rail, and my 12-volt wire to my 12-volt rail. These things will catch your fingers if you're not careful. So now I'm going to connect the power connector to the rails, to the 12-volt, and to the ground. Normally we'd have a power button. I'm not going to put the power button in. I'll put that in when we put everything in the box. But for now, we'll just connect the power directly to the power rails. Now I'm going to install the 5-volt rail. I'll just clip one of the DuPont connectors off of one of my Arduino wires, and we'll go ahead and just strip that. One end of this is going to connect to the 5-volt pin on the shield. There are two 5-volt pins. There's one in the top right corner. It's with the third pin down. I'm having a hard time seeing it with my eyesight. And then the second pin is right here. I prefer to use this one, although I'm not sure it matters which one you use. I think I put a multimeter in there, and they're both on the same rail. And this is the other pin. So we'll simply connect this to another connector, a rail, and this will be our 5-volt rail. The next thing we're going to install is the proximity sensor. So I've already put a DuPont connector on the black wire. The brown wire goes to 12-volt positive, the blue goes to ground, and the black will connect up to the shield. So this schematic can be found in the Arduino code folder in the GitHub repo. And I'm going to put this to X plus D9. There's a better schematic in the Instructions.PDF, which is in the GitHub repo. Now we're going to install our feed sensor. So again, I've installed a DuPont connector on this signal wire, and the red and black are going to connect to our 5-volt and ground rails. The white wire is going to connect up to D10, Y+. Now I'm going to connect up the sorter homing sensor wires, and I labeled it. Same thing here, we're going to put red to 5-volt, black to ground, and white to the signal pin. This one's going to go to Z+, which is D11. And that's the last sensor we need to install. Now we're going to take our repurposed motor cable, and 2 of these wires are just a 12-volt connection to the fan, the blower fan on the camera module. So red is hot, 12-volt plus, and then blue in this case is going to go to ground. Now we're going to install our dimmer, which is a motor dimmer, but it's also great for LED lights. If we take a look at the back, the DC in is going to be a 5-volt connection, and we're going to have 2 wires that go out to our light ring. In this case, I'm using the green as the positive wire and the black as the negative or ground. I've also labeled it with the C to know that this actually goes to the camera light ring. On the DC in side, I'm just going to be connecting it to our 5-volt rail and to ground. Lastly, we have to install the motor cables. Now, I put some red tape around the feed motor. That way I don't get it mixed up. It's also on the other end of the cable. And the feed motor is the motor on the left, or the motor controller, which is closest to the reset button. It's a little hard to get that in there, and I was more focused on getting it connected than the orientation. I realized later that these are backwards. So the black wire should face towards the inside of the shield, and the red wire towards the edge. So I actually installed both of these backwards. And the result of that is when we go to test it, we're going to see that the motors are running the wrong direction. So we also need to remember you can't just pull these wires when the system's powered up. You need to disconnect the power to the system before you pull motor cable wires. So now we have the system connected to our computer and powered up, and I'm doing a test. So I'm simply hitting the enter button in the serial console in the Arduino, and I can see that it's feeding, but it's feeding backwards. So I'm going to have to flip those wires. I guess this is the punishment I get for going too fast. Oh well. So after getting those motor issues sorted out, I connected the software and was checking out the camera imaging, and noticed there's a lot of brightness. So I went to the fine-tuning settings, and you can see a big halo around the brass. The brass is pretty washed out. So I can fix this by tweaking the sensitivity settings, but really what we needed to do was reduce the amount of light we had in the system. Previously, I was connecting the dimmer to 12 volt and using a 4.7K resistor. And I was hoping that by going to 5 volt, I wouldn't need to use the resistor, but it looks like we're going to have to put a resistor into the system. So I got out my book of resistors and took a wild guess based on my previous experience that we probably needed to be around 1K. I went with 1.2K, which ended up working really well, as you'll see here in a bit. I soldered a resistor to the ground side of the output of the dimmer. I also used heat shrink tubing just to make everything more secure. Coming back to the software, now you can see the halo is gone from the images, and we're getting a really nice black background, and that's super important. We can reduce our scan sensitivity quite a bit, as our pictures are looking a lot better now. So I went back to the configuration tab and previewed the camera, and here I'm adjusting the potentiometer to see what kind of light range we have. And you can see at the very bottom it gets dim, and then towards the top it's a little bit too bright. But it still gives me a very good range to work with. Finally, we want to set the voltage or the current on our motors. And this is going to require a multimeter. What we want to do first is unplug any power you have to the device, and then we're going to unplug our motor cables. Per the manufacturer's recommendations, you don't want to have the motor cables connected when you're setting the voltage. I'm putting a ground clip to the ground pin. To all these black pins against the edge are ground, and that's connected to the ground side of my multimeter. There are 3 pinholes on the controller. In this orientation, it's going to be the one that's to the top on the right, and that's going to give us a vRef, a voltage ref. And you'll see from the factory these are set to about 1350. And I'll pull that cheat sheet up here, but that's close to about an amp. And I want to go a little lower than that. I like to set mine around 1250, so around 0.9 amps. One advantage in going a little bit lower is that the motors stay cooler. And if you find that you're dropping steps or there's not enough power to move stuff, then you can always turn these back up a little bit. Here's a close-up look at those pins. And it's this top pin that's going to give you the voltage ref measurement. I was shooting for around 1250. I'll take 1220, 1230. That should work well. And with that, we're pretty much done, ready to put stuff in the enclosure. Alright, so in this step we're just going to gather up our wire and our Arduino and stuff her in the box. And once we get it all in there, we're able to put the lid on. We forgot the fan. And now we're good. We're good to go. Thank you for watching. You didn't think I'd leave you hanging there, did you? So let's get to it. First of all, we have this 40mm fan. And we have these small little nuts, these M3 nuts we've got to align with the fan holes. Once you have those in place, we'll want to keep them there, so we'll turn it up on the side and get those screws in. So I don't have much use for this connector. I'm going to cut it and we'll strip these 2 wires, and those will just get connected to our rails, our 12 volt and our ground rails. So I've never been good at killing 2 birds with 1 stone, so I guess I'll have to give this another try. There we go. Now we're ready to install the dimmer. This is pretty straightforward. It's only going to fit in 1 hole in the enclosure, which is on the bottom. So we'll push that through, put the locking nut in place and tighten that down, and press on the knob, and we should be good to go there. Now we're going to install our power switch. So we'll just poke that through the hole and screw the nut on. Next we have the 12 volt jack. And so I have a pre-wired jack, which I prefer. I would recommend, if you don't have the pre-wired, that you pre-wire it. We'll pop that in, put the nut on, tighten it down. Now I'm going to solder the power side of the jack to the open lead on the power button. Soldering obviously isn't my thing, as you can see by the results here. The other side coming off the power button is going to go to our 12 volt rail, so that when the button is turned on, the rail is energized. We're going to install the Uno now. This is pretty simple. We're just going to place it over the mount points and add the screws. I know, I robbed you of the joy of watching me fumble putting these in. Generally, I only put a couple in, but this time I decided to put all 4 in just to set a good example. Here you can see I've run the power wire under the Uno, and now we're going to snap the shield down on top of it. which is easier said than done. Once it's in the box, it's a little bit hard to line those pins up. And for those of you who are into looking at fat thumbs, well, this part of the video is for you. One other thing I'd like to mention is that I wouldn't run the power wire under the Uno like I did here. I was getting power spikes that were crashing the Uno. I think I'll run it along the side next time. The last part here is just me wiring up everything again. So exactly like we did before, except now we have stuff in the box. You can definitely spend more time on wire management than I did here. I was just trying to get this thing done. At this point, I'm going to stuff all these wires in the spaces, trying not to disconnect anything. So I'll find a space for it. The other thing I don't want to do is I don't want to jam the fan. Obviously this could be done in a much nicer way, but at this point I was getting tired and wanted to just finish it up. Lastly, I would use some cable management wrap or cable protector wrap to wrap all these wires together and just make everything look nice. Alright, we're looking at the system. We have everything plugged in, all of our sensors, our camera, fan, and light control. You can see the connector with the lines on it there. And I've put female and male or male on the camera side and female coming off of the box. Used my electrical tape for cable wrap, and here you can see the motor is plugged in and routed, as well as the sorter motor and the sorter sensor. Alright, I want to come back to this and do a little bit more cable management here. So I'm just going to grab a couple zip ties, and this new bracket, the nice thing about it, up with all the holes, is that we can zip tie stuff to it. So I'll put a couple zip ties here and clean things up just a bit more, and then we should be ready to run our machine. Well, that pretty much concludes the building of the electronics enclosure and the electronics. And because every movie should have a happy ending, I'm going to leave you with the sweet, sweet sounds of the AI sorting brass. Have a good day, y'all.